Hi guys, and welcome to yet another devcast, which will be probably this year's last devcast. And it's a special one since it's a sneak peek, and I am showing you for the first time a new tool, an API I'm working on for procedural generation in Unity. It's called Progen, and you may already saw some parts of the left side of the screen, which is the wave function collapse generator with the analyzer that analyzes an existing pre-authored prefabs and extracts the tile definitions as well as neighbors from them. I'm not going to focus on this one. Wave function collapse is a well-known algorithm that you can use to generate the final layout. You can even multipass it to generate various final steps for your procedural generation. But to put it simply, by itself, without any constraints, it generates two random content. So you want to guide it into generating something more specific, like in this case, I generated this layout, which constrained all these tiles, these red tiles, to be floors, and all the other stuff is basically generated by this, so the correct neighbor pairs, correct walls, and so on, and all these additional content is generated by the wave function collapse. So I'm going to focus on this part that I didn't show yet, which is the right one, which is the layout generator that can be used and fed into the wave function collapse as a constraint. And you can also take it as a separate generator that you can use for your own procedural generation uh, as a constraint or something entirely different if you want to. So let's start. As I said, this is the analyzer, this is the pre-authored prefab which was analyzed into these tile definitions and their correct neighbors. And then you can run the generator and it will generate random content. Sometime there is no backtracking, so it converges to a failed state basically, but uh, it happens with these types of generators. It can be fixed, but we don't really need to, since we don't use it at the runtime yet. So as I said, this is a two random content. So I want to constrain some of these to a pre-authored stuff, or at least pre-authored based on high-level rules, like have at least two rooms of such and such size and so on. So I'm going to focus on this layout generator, which will be used to do basically that. So let's create a new layout. Let's call it the devcast, just for fun. So there are four parts basically. First is the source part, which is what we are starting with, which is width and height, or we can start with a specific layout if you had one. So you can cascade the layouts if you want to. So this layout can be input to another layout as well. You just cannot input the layout into itself, obviously. Then there is the width and height, as I mentioned. Then there is a set of processors that will basically generate the layout for us. Then there is a preview which shows you what's currently the output of this layout, and then there is the layout asset itself. There is a red output. You may ask why there is a red output. It's because red is a default color for no value. Because the layout can have values from 0 to 255. It's basically a byte-based layout, but I wanted to have an option to have no value inside the data. So, for example, if I want to specify negative space as well as positive space, I couldn't have 0 as a no value. I had to have something outside of that range to specify there is no value. So you can have only the constraints that have a valid value active on the wave function collapse or anything you want to. So let's start with the processor, which is first processor that I'm using. This is my favorite processor. It's a well-known algorithm. Is a cone chain, which is a Markov chain, Markov chain Monte Carlo. Uh, method which uses Metropolis Hastings algorithms to basically map probability distribution of samples into output used n by n patterns. So the theory is not really relevant here. You can look it up. There are a lot of implementations for various languages for this, but for it what it does, it takes. Let me show you on Cave. It's really good. It takes this sample and then tries to basically map it using a 3 by 3. It's a hard-coded pattern. I can change it if you want to do into the output. The more iterations you have, uh, uh, the closely the distribution matches the sample. So if I do 10, you will see that it converges to the sample, at least by the grid pattern itself, and I can generate various outputs using this sample. Uh, we will we are going to generate a maze here, so that's why I use this kind of sample. I will also add implementation of multiple inputs, because you can have multiple inputs with different weight distributions, and you can map it and combine them together. So it will be even more fancy, but the algorithm is basically the same. But as I said, this is very similar to what actually the wave function collapse does. Not the algorithm itself, but the output is very similar. So I want to constrain this in a way, so I have more control over the output. So what I can do here is enable constraint, and what it does, it takes the constraint that I will specify later, and say to the algorithm that this is constraint basically point, and it should have this value. It's still valid for the algorithm itself, because it affects the sample matching around that value, but it will be that specific value. So let's add some kind of processor that will enable me to paint, which is paint processor. I will put it before this conf chain. As you can see, this is what I actually said. You have no value there, because I want to be able to paint black as well as white pixels, so positive and negative space. So I want to have a room somewhere here. So let's paint it. Let's make it more big. Oh, I want to have the room, so it should be white. It generates the output, as you can see, but there is still now you can see that the room is there, so it will be included as a constraint into the output itself. What I can do is, if I had a different layers or different processors behind this, but I want to still use this one as a constraint into the chain processor, I can specify this as a layer. So you can specify any layer that was generated before this one in the chain of processors. So if I didn't do this, it still will be the same, because there is nothing between this processor and these processors. But I can add some other stuff later. So that's what I meant, that you can specify a constraining layer. This is basically an export for this particular stuff, and you can then use this as an import. You can also specify a different layout completely different asset as a constraint for this. So that's nice. Let's play with it a bit more. Let's say that I want to have this kind of like dungeon or something. So it generates for me. Nice. But still, this is a bit too much. For example, if I look at the preview, this is completely like stupid. Why do I need this one? The player will not be able to go here or even here and so on. By the way, I can also preview any layer that I exported or that I specified as a layer, so you can preview that. So what I need here is an additional processor, which is flat fill processor. And flat fill processor is a very specific processor, but you all know what flat fill is. It basically takes a point, or in our case, a layer, because you can start a flat fill from multiple points at once. It doesn't need to be a single point. And then try to fill the whole layout using that source. And again, you can specify a constraint for that fill. So basically, we take a point and tell it to flat fill, but we will constrain it to a specific area. So let's take this processor as a constraint, which is in our case it's an input, and we don't really need to specify a layer. I could also specify a layer here, but again, there is nothing between these two, so it will be this constraint layer and this input. And we can tell it to use as an input for the flat fill start this constrained layer. So we will start the flat fill only from this, because now we'll see that everything is filled because we started from this. So we started to fill every pixel that we see with the value that it already has. So we just want to start with the constraint. And now we see that we just basically took this and run the filter into this one. So it all run the flood into this one. So it only flooded where it actually could go. So it couldn't go here and so on, because there is a negative space between us. So now I can also generate various outputs with this method. I can also obviously paint additional stuff that needs to be there and so on. And as I mentioned, I can also paint negative space, which means that if I go here, there is for example this kind of stuff, but I want to be sure that there is nothing, that there is a wall or empty space behind this room, or also around this room as well. So it will constrain the flat fill with negative space as well, and there will be nothing generated around that room, as we can see now. Even though I change the seed generator, this room will always be surrounded by a negative space. And we can also take this and use the devcast layout, and I show you the gizmos, and you can see that it constrains, or would constrain if you generate. We are not going to generate because this layout doesn't really work for us, as we don't have tile neighbors that can put two walls inside a single grid line. But just to show you that it automatically projects the constraints into the wave function collapse. But you can use this kind of generated layout for anything you want to. So you can also paint additional values there for doors and stuff like that. There are other generators that I'm working on, and some of them already work, like for example like Perlin noise, and then you can use randomly distributed points with A star to generate cave systems, very similar to my other presentation I did on puzzle or on Digi's Adventure Dungeon Generator. You can check it on my YouTube. You can also use a generator for with particle emitter distribution that basically carves the path for the positive space in our layout, and so on. So that's it basically for this sneak peek, and I'm very curious about any kind of feedback and what are your use cases for such a procedural generator, or what would be your use cases, and what would you like to see in these uh, in these type of layout generators. I can say here already that I have some processors that I tried. I'm not going to use them, but they, similarly to the ConfChain processor, they gave me an idea for another type of generator that will not be used for layouting, that will be used for procedural textures, but that's something for a completely different webcast that I may or may not do. But that's all from me for today, and thank you for watching.